in this problem, I1 needs to be found, I2 needs to be found, and V0 needs to be found, and the power through all of the components needs to be found. So again, the first step to note is that this is all one wire, so it's all one node, so I'm going to make it dark so I can remember that. And up here I also have a junction, so this is another node. I can either sum the currents down here or up here. Before I do that, I need to make sure I know all the currents going through every resistor. So over here I have that the 1 amp is going down, it's just a bend in the wire, so this is all just one branch, and so this current is going to be the same, 1 amp. Positive to negative, positive to negative. Positive to negative, I1 goes here. I2 just has a bend, again it's just the same branch, there's no split, it just bends, so I have I2 here. Plus to negative and plus to negative. So if I sum the currents here, I have I2 going in, I1 going in, and 1 going in. So I have negatives for each one of those. I can solve this for, again, arbitrarily I1 or I2. I'm going to choose to solve it for I1. So I1 will equal a negative I2, negative 1. Now I want to do a voltage loop. I do not want to take a voltage loop through a current source. So I'm going to ignore this branch over here, and I'm going to take a loop just here. I can either take the loop in this direction or the loop in this direction. Either way, I'm going to choose to do it in this direction. So going around in this direction, I come up here, I have a plus as my second sign, and I have a plus, and then I have a minus. So coming up, my voltage across any resistor is I times R, so this is going to be a plus I2 times 20, then a plus I2 times 30, then I come down and it's a minus I1 times 10 equals 0, and I can combine these to 50 I2 minus I1 times 10. Now I have an equation with I1 and I2 and another equation with I1 and I2. So now I can substitute I1 in here and have one equation in terms of just I2. So 50 I2, and I plug in for I1, which is a negative I2 minus 1 times 10. Again, that's just rewriting it. So now the negatives all become positive. Negative times negative is a positive, so I'm just going to do that. Combine all of the I2s, that gives me 60 I2 plus 10 equals 0. So I2 is a negative 10 over 60, or a negative 1/6. And that's in amps. So now I plug in I2 up here for I1, and I get a negative negative, so plus 1/6 minus 1. I'm going to make that 1 into 6 over 6, and I get a negative 5/6 amps. Now V0, which is here, is I times R. My plus and my plus are on the same top side. So that means I'm going to have a positive I2 times 20. Again, if they were opposite signs on the top, then it would be a negative I times R. So I take the negative 1/6. So this is negative 20 over 6. And this is in volts because it's voltage. So negative 20 over 6 volts. So now I want to find the power in each component. So to do that, I'm going to take I times V, or I take I squared times R. So power is equal to I times V, or it's equal to I squared times R. Our values over here, I2 was -1.6 amps, I1 was a -5.6 amps, and V0 we found as a -20/6 volts. So the first one we'll do is in the 20 ohm. So the current going through it is I2, so it'll be I2 squared times 20. And that gives a negative and a negative, so it gives positive. So this will be a positive 20/36 watts. And that looks correct because I have a positive quantity. For every resistor, it should be a positive quantity, meaning it's absorbing or consuming the power. The power in the 30 ohms is going to be similar. It's going to be I2 squared times R. In this case, the R is 30. So here I have 30/36 watts. For the 10, I have a I1, which is a -5.6 squared times 10. So I get 250/36 watts. And the last one, which is the power over 5 ohms, going through it I have 1, so this is 5 watts. Combining all of these and summing them up, I would change this to be 5 times 36/36. Adding them up give me 480/36, or I can write it as 80/60, or 80/6 watts. So that would be the combination of all of these. I'm doing this so that I can check that my source is generating and producing that same amount. That will check my answers to make sure they're also correct. So now I need to find the power in this 1 amp source. So to do that, I need to find the voltage. I'm going to just label that as Vx, and power for this 1 amp source is going to be the current, which is 1, times now this Vx. So I can take a voltage loop with Vx in it, and I'm going to just choose to take it here. So going up would be plus I1 times 10. Here I go through, the top sign on there was the positive, here's a negative, and here's a negative. So plus, negative, negative, so plus I1 times 10, negative 1 times 5, negative Vx equals 0. I1, I plug in as the -5.6, and I solve this for Vx, which will give me that Vx is equal to -80/6 volts. So the power is going to be 1 times that, and that does match the watts that I had through all of the resistors. The summation of that was the same.